Okay, we're going to talk about two other types of dilutions besides simple dilutions, a dilution series and serial dilutions. So first let's talk about a dilution series. So in a dilution series, you're given stock and you're going to add 1 ml to this first test tube and 9 mLs of your diluent. You're going to use the stock again for the second test tube, but there you're just going to put 0.2 mLs and 9.8 mLs of diluent. And into your third test tube, 0.1 mLs and 9.9 mLs of diluent. So let's take a look at what doing that has done to our concentrations. So we're going to have 1/10 of our stock concentration because it's 1 ml in 10 mLs total. In the second test tube, we have 0.2 mLs out of 10 mLs total. So we can also look at that by moving the decimal point, 2 out of 100 or 1 out of 50. So that gives us a 50th dilution. That's our dilution factor there. And here, again, 0.1 out of 10 is 1 out of 100. That's our dilution factor for this third test tube. So that's a dilution series. It's just a series of dilutions, 1/10, 1/50, and 1/100th of dilutions of our stock solution. So a dilution series is a little bit different from a serial dilution. So I'm going to give you two examples of serial dilutions. So if we start with 1 ml being transferred to this test tube, which already has 1 ml in it, it's going to be 1 ml out of 2 mLs. So then we mix well that 2 mLs, and we take 1 ml of this 1/2 dilution and add it here. So we're doing a 1-to-2 dilution because it's 1 ml to 1 ml, so a total of 2 mLs. But the final dilution is 1 out of 4 because we have 1/2 dilution here, then it's half diluted again. Same here. If we take another ml, we have to make sure we're mixing these well before we're transferring that 1 ml so that we know the concentration. But here we're going to have 1/8 because this concentration is diluted by 1/2 to give us 1/8. So you can repeat that. They all have the same dilution factor. In a serial dilution, it's a series of dilutions where they each have the same dilution factor, but the final dilution is going to be, here it's an 8-fold dilution. Total dilution, 8-fold total dilution. It is a 2-fold serial dilution. Because each time the stock solution is being diluted, well, the first time the stock solution is being diluted 2-fold, the second time this first dilution is being diluted 2-fold, the third time this second solution is being diluted 2-fold. So overall, in your last test tube, you have an 8-fold dilution, but each time you're just doing a 2-fold dilution. So that's why it's called a 2-fold serial dilution. And I'll give you one more example of this because it's a little more complicated than a simple dilution or a dilution series. So here we have a stock solution, and we're taking 1 ml of stock solution and adding it to 9 mLs. So So we're diluting that 1/10. Oops, I'm sorry. It's not a dilution series, so we're not using that. You mix that well and add 1 ml. Again, each time we're going to add 1 ml to 9 mLs for a total of 10 mLs. Each time your dilution factor is 1/10, but each time you're diluting your original concentration more. So here, and let's just go ahead and finish this out. Each time you're doing a 1/10 dilution, but each time you're getting more and more dilute. So ultimately, this is 100,000 fold total dilution. It is a 10-fold serial dilution. And just for the sake of looking at these numbers, you can also always express using scientific notation this as 1 out of 10 to the second, this out of 1 to 10 to the third, or this is just 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, and 10 to the minus 5. If you remember your scientific notation rules, this means 1 over 10 to the second by having a negative exponent. So you see how each time we're diluting the same dilution factor, but we're getting more and more diluted solution because we're taking 1 ml of a diluted solution into 9 mL of diluent, and then taking 1 more ml of that even further diluted solution. So serial dilutions are something you have to think a little bit more about. They may be a little bit more complex when you're trying to determine the final concentration. But if you just work through them, you'll be able to come up with your solutions.